Hello, everybody, and welcome to the new year and our winter mentorship mini series. I'm Dr. Dan Kalish, and I'm here to talk to you about a challenging and kind of fun lab interpretation breakthrough. Let's call it a breakthrough. I'd put it in the top 10 most important things I've learned in the last 10 years, so I want to talk about it. And we'll talk about how this manifests. We'll talk about how you can see it on lab testing, and we'll talk about supplement protocols that you can use to fix it. And I'll talk a little bit about the history of all this and the history of the labs, really. I think it's important to maintain the history of our profession. And I'm part of the history now. I'm kind of old. So, not that I'm trying to preserve myself in any way, but I want to make sure that, all the things that I've learned are passed on to the next generation. That's really the main purpose of my work these days. So for those of you that are brand new, I'm Dr. Dan Kalish. I've been in practice for 31 years. I've been teaching classes for 20, 25 years. And I've had a goal for the last 25 years of increasing the number of well-trained functional medicine practitioners, specifically in lab interpretation, development, and developing those skills, and perhaps even more importantly in patient communication skills. When I was doing some exit interviews with our one-year mentorship students a few months ago, and I always ask them, so what did you learn? What could we do to make the class better? What really made the difference? And a lot of them said, I'm expecting them to say lab interpretation. I didn't know that glycine marker was so important. That's what I'm thinking about the facts. But a lot of them really reflected back on it was about patient management and about how to handle difficult situations and about how to develop sequences for supplement programs and protocols for the different labs that are mixed together and how to run the practice and all the inner workings of what really has to happen to make a practice work. So we try to include a lot of that in these classes as well as in our paid courses, so that you guys can get a leg up on what you're trying to do here with your practice. And then for today, our specific topic for today is thyroid patients that just aren't responding. You diagnose them with a thyroid problem, you looked at all their thyroid labs, you put them on either a supplement program that usually works for your thyroid cases, or you put them on a prescription program that usually works for your thyroid cases. You maybe even retested their thyroid labs, and the labs look better now, but they're not better. They're not feeling better. Why could that be? And so we're going to start off today with a quiz question. And I hope you guys, there's no cheating. This is a closed book test, okay? So don't go on Dr. Google and try to look this one up. But it's a little sort of matching game that I like to play. So if I say like a hormone, or I say like a function, you think of hormones. If I say something like pancreas, and we're talking about hormones, you would think insulin. And then I would say, well, what does that do? And it says regulates your blood sugar. That's pretty easy. Or if I said estrogen, you would think ovaries. And then what does that do? You say, well, it's a female reproductive hormone, obviously. And so here's the quiz question, though. This is the hard one. And I really actually seriously want you guys to try to type in the answer if you think you know what it is. So if I say thyroid, I mean, the pretty easy part is that you would say, okay, well, thyroid hormones, because they don't have a different name. We just call them thyroid hormones. And then I say, well, what's the mechanism? Like, what is that doing? And then we all learned in school, well, it's controlling your basal metabolic rate. And now people typing in answers now. So we've got metabolism, mitochondria energy production. And so those are, by the way, everyone that's getting this right is a former student of mine, okay, in the mentorship class. I'm trying to find, and I recognize you, Suresh. I see you, J.E. I get all your names here. Jane is there. Everyone that's answering it right was a former mentorship student. So that is kind of a little bit cheating because they've heard me say this like a thousand times in class. But the point of the question is that when we think about thyroid and thyroid hormones, we think about metabolic rate, but we don't think then the next step, which is like what's carrying out that metabolic function. How is that actually in action in the body? Where physically is that happening? And now you're kind of thinking, well, I don't know. I guess it's happening pretty much exclusively in the mitochondria. So what does that mean? If your mitochondria are not working and you fix the thyroid, who's the thyroid going to boss around? Who's the thyroid going to tell what to do? Nah, there's no one listening, right? The thyroid doesn't have an audience if the mitochondria are not paying attention. And what's even worse than the mitochondria not paying attention, and this is what we're talking about tonight, which is when there's physically not enough mitochondria present. They're just not there anymore. They have gone away. And Dr. Richard Lord, who taught me this concept and has been my teacher for the last 12 or 13 years, discovered this concept, really began to formulate it back in the 1960s when he was in graduate school getting his PhD. And back in those days, he was thinking about how can we do biochemical analyses? How can we do individualized nutritional programs? How can we see what genes are working and not working, what enzymes are working and not working, specifically when it relates to metabolism? And so when he graduated from school and he started to work in one of these lab companies, he realized that, hey, we could do organic acids testing and amino acid testing and fatty acid testing as a means for assessing metabolic function and metabolic health. And so 35 or 40 years went by, and everybody in the field, including Dr. Richard Lord, who developed all these tests originally for us in functional medicine, thought that the only markers that really mattered were markers that were elevated in terms of mitochondrial metabolites. And we're going to look at all these labs. So if you're not following some of the words I'm throwing out there, don't worry. In a few minutes, we're going to look at all the lab tests. You'll see what I'm talking about physically on a lab. And so then, I don't know, 10, 12 years ago, it started to be, show up in the scientific literature that low mitochondrial markers were actually very significant too. And what low mitochondrial markers showed was a lack of mitochondria being present. And this just upended the entire field of organic acids testing, because you've got a group of people who've been for 50 or 60 years only looking at markers as being a problem when they're high. Now realizing, oh, I guess there's a whole different problem happening when these markers are low. And that information, that scientific breakthrough has not really, bled out is not really the right term, has not really leaked out, has not really gotten out to to our industry in general. And so Richard taught me this, quite a while ago. I use this on my cases in my practice with Richard's assistants, these protocols that I'm teaching tonight. And he and I were both shocked to watch it work really effectively as it's measured on follow-up organic acids testing. So what tests are we talking about? If you're using DSL lab, we're talking about the omics or organic acids from Diagnostic Solutions. We're talking about the Genova, Nutraval, or metabolomics test. Or if you're using Great Plains, which has changed their name to Mosaic Lab, you're talking about the OAT test. They're all the same, okay? OAT test, they're not all the same, but they're the same concept here. Metabolomics, Nutraval, the OAT, the omics, that's what we're talking about now, okay? So let's jump in and take a look at this overall subject. And I'm going to skip around. I'm just using these slides as reference. I'm going to skip through them. And if you guys ask questions, I'm going to be able to come back to the slides. So this is not a linear presentation where we're going to read each slide, just so you know, I'm not forgetting anything. Oh, the first slide's about me. Hi, I'm Dan. I've been doing this for a long time. We've trained 7,000 people. I did a research study with the Mayo Clinic, which was kind of like a big deal in my, personal emotional world. I'm IFM certified. I've been in practice forever. Oh, and this is what I'm supposed to talk about. Get out your phone and scan that code, that QR code. Number one, because I really, really, really like QR codes, and I think it's so cool that my office can generate them now. And number two, because we are launching for the first time a series of certification programs called Level 1, Level 2, and then my mentorship program, which has been around since 2006. So this is the first time we've ever announced this. I'm pretty excited about it. We've been working on this for several years. And Level 1 certification includes 4 specific boot camps that I've set up as an entry-level series of classes on lab ordering and the very beginning of lab protocol design, skills development. Okay, it's about a year-long program. There's 4 different sections to it. You can take the classes separately, or you can take them all together and get certified either way. Then the Level 2 is much more advanced boot camps. They're longer, they're more complicated. They're really for practitioners who've been doing this for, I don't know, like at least a year, let's say. Probably not the first class that you'd want to take. Level 2 is a little more advanced. And then the mentorship is open to anybody at any level if you really want to spend a year devoted to doing this work. So again, Level 1, protocol design boot camps. Level 2 are these workshop intensives. And so again, Level 1, you're learning how to do protocols. In Level 2, we're diving much deeper into how all these work. Everything is posted on a website right now. You can scan these codes and you can see the certification page on our website. You can see all the classes page. Everything's up and running for the year. And we've got quite a few new things that we're offering. And again, you can take these classes a la carte. You can take one workshop and one protocol class, or you can take a whole series if you want to get certified at a certain level of either level 1 or level 2. And then if you want to join the mentorship, as always, you're welcome to do that at any time, okay? Okay, so now, I don't know, it just seems helpful to start with the end. And the end is what we're going to be using. So you should know all these supplements already. If you don't, I'll just go through them, briefly. You should be very familiar with free-form amino acids. Those are always used in a powder. I guess you can buy them in pills, but nobody usually uses them in pills. A typical dose of a free-form amino acid powder is around 1 teaspoon or 5 grams twice a day between meals. What we're going to talk about today is a special use of those free-form amino acid powders where the dosing is double that. Okay, so for a different purpose, we're going to talk about that. And then CoQ10 is essential, PQQ, B vitamins, some kind of generalized mitochondrial support that could be a multivitamin or it could be one of these mitochondrial boost type programs, supplements. And then tryptophan has an extra special place. Of course, that's in many of the free-form amino acid powders, but if you look at the bottle and it's not in there, don't forget about the tryptophan. That's often left off, even though it's one of the 20 amino acids that you need to synthesize protein. And what we're talking about tonight is correcting your body's ability to synthesize protein, to make proteins, so that you can make mitochondria so your thyroid has someone to talk to. So if there's physically not enough mitochondria present, the thyroid, even if it's got all the hormones in the world, is not going to have a metabolism to direct. So we want to increase the numbers of mitochondria by using these types of supplements based on the lab testing in order to get the mitochondrial populations back up. This is a pretty hot subject in science now because poor mitochondrial function is associated with pretty much every disease. I was wondering where to even start, but obviously diabetes, high triglycerides, high cholesterol, atherosclerosis, high blood pressure, dementia, depression, anxiety, chronic fatigue, autoimmune problems, long haul COVID, short haul COVID, whatever COVID vaccine reactions, just about every condition that we treat, chronic pain, has got a mitochondrial component. And if the patient is perfectly healthy, which I hope most of your patients are, then another, in my mind, even better use of these programs is for a wellness or longevity program. For someone that's already healthy, that wants to stay healthy, if you can increase their mitochondrial populations and strengthen mitochondrial function, that is literally the key to eternal life. And I don't want to really live forever. I don't know how long I want to live, to be honest. I've thought about that a lot, but I'm not really sure yet. But I certainly want to live a healthy life until the end, whether that's 80, 90, or 100, or whatever it may be. And keeping your mitochondria healthy and fit are the keys to keeping your body healthy and fit, even if you're already healthy. This, in a sense, is even more important because we can prevent people from falling apart and developing problems like Alzheimer's, diabetes, et cetera, heart disease, if we, mind the mitochondria and keep them fit and healthy as well. So now on the thyroid side of this, a super common problem. Millions of Americans have this issue. You guys see it in your practices every day. Sometimes it's autoimmune, sometimes it's not. Most of the patients are female, but once in a while you see a male with it. And there's a relationship between the thyroid and stress and thyroid and the adrenals, so we don't want to skip through that. And then you're used to these symptoms as well, anything from fatigue to glucose intolerance or insulin resistance, problems with weight gain, heart disease, etc. And there's a really strong stress component to thyroid, so we're not dissing the thyroid treatments here. We're assuming that these have already been done perhaps, and you're not getting a response, okay? And then if you have questions, just type them into the box and I'll try to get to them at the end, as many as I can. So the problem then can express as hypothyroidism, which we're all familiar with, and the depression and the weight gain, the problems with skin and all that. And you can also have problems with the adrenals that are very similar. But what we're talking about is when these problems are present, you've corrected the thyroid hormone production, you've got the thyroid working either through natural treatments or through prescriptions, and the person's still not better. So we're not ignoring inflammation, stress, infection, dietary factors. We're assuming you're controlling for all of that. And we're just getting really deep into this one specific topic here. Okay. And these are my thyroid slides, but we're not too concerned with those. We want to start with this. But okay, we're assuming a lot of knowledge here on thyroid that has already been, taken care of. But this is where we want to start, right? With that as a background. So let's take a deep breath and look at this. Tissue regulation by the mechanistic, sometimes also called the mammalian, target of rapamycin, or mTOR. Sometimes people just call it TOR if it's not a mammal. So generally, when you think of mTOR, or hear people speaking about mTOR, they're talking about preventing mTOR from activating itself because they're trying to have this whole, longevity effect. And the one group of people you don't want to do what we're talking about tonight with is with cancer patients, because you don't want to stimulate and increase protein synthesis, obviously, in someone who already has a problem with excessive cell growth. So as long as this person does not have cancer, doesn't have a history of cancer, then we can move forward by stimulating mTOR, not for very long, just until we get normal mitochondrial populations back. Okay? And that turns out to have an effect globally throughout the body, because as the mitochondria come back online, you're going to improve everything from metabolic function to hemoglobin levels to immune system function. It's a global correction. It doesn't only affect mitochondria because we're stimulating protein synthesis in the largest sense throughout the body. And so how do you do this? It's really not that complicated, but it's very dose dependent. If you get the dosages wrong, it doesn't work. I'm not going to tell you the dosages until the end. No, I'm just kidding. So I'm going to tell you the dosages right now. So I said already, everybody uses amino acids, free-form amino acids when people need them at 5 grams twice a day. That's about a teaspoon twice a day. And it's got to be on an empty stomach or it doesn't work. If you're trying to stimulate mTOR, you want to bring it up to between 8 and 12 grams per day. Let's just call it 10 to make it a nice round number. So in order to stimulate mTOR, you need 10 grams or 2 teaspoons of free-form amino acids at least once a day. Twice a day for some people is probably preferable if you really want to get the ball moving quickly. It's got to be on an empty stomach or it won't work. 5 grams won't make this happen. It's got to be around 10 grams per dose. That's the secret sauce to making this work. If your amino acid formula does not have tryptophan, and many of them do not have tryptophan, then this is not going to work. So that's why I wrote tryptophan as a special little thing there. Easy enough. You can still use that product, just add the extra tryptophan in. Buy some tryptophan from a company and do that. So amino acids and their roles in protein synthesis. We're trying to stimulate mitochondrial growth so the thyroid has a sounding board. So there's a repair or restoration of the metabolism. And then your thyroid treatments are all of a sudden going to start to kick in. I guess it's implied that any level of mitochondrial problem is involving the thyroid, but I'm trying to explain this in a way in which we saw it appear clinically quite frequently, which was doctors coming into the mentorship and they're like, I don't know, I'm doing all these thyroid treatments, the person's not any better. What do you think I should do, Dr. Kalish? I'm like, well, let's look at their organic acids. And lo and behold, each one of those patients was hypometabolic. That's what Richard calls this syndrome, not enough mitochondria. Hypometabolic, sometimes Dr. Lord refers to it as mitochondrial retraction, meaning a reduction in the numbers, not the function, but the numbers of mitochondria. Reduction in the function of mitochondria is very bad. Reduction in their absolute numbers is catastrophic. And these people have fatigue, depression, all kinds of chronic pain syndromes. It's really quite remarkable. Okay, so treatment-wise, amino acids and their roles in protein synthesis. So not only are we trying to stimulate mitochondrial growth, but as a side effect, we're going to improve insulin, hemoglobin, antibodies, collagen production. It's going to improve protein synthesis throughout the entire body. Enzymes, these are all proteins. Everything that we're talking about enzyme-wise is a protein. Which enzymes? Okay, well, how about cytochrome P450 enzymes that run your detox pathway? How about pyruvate dehydrogenase? all the mentorship students are laughing now because they're so tired of me saying that term, because it's like my favorite enzyme. I talk about it a lot. But anyways, it's a really important one for, you know, your blood sugar regulation, pyruvate dehydrogenase, super important. And it looks really cool too when you see a picture of it. Lactate dehydrogenase, equally important. Succinate dehydrogenase, that's kind of like the most important one you could possibly imagine. All these enzymes are proteins, and if you don't have enough protein synthesis happening, and what are the odds that you're going to not make enough mitochondria, but you're going to make everything else perfectly, like zero? That can't happen. So if you have mitochondrial retraction, if you have not enough mitochondria, it means that this whole concept of making proteins is screwed up. That's why these people don't just have one problem. You're never going to see a person who just has low mitochondrial populations and everything else is fine. Like their detox pathways are fine, and their blood sugar is fine, and their citric acid cycle is fine. That's not possible because they're all linked together by this common concept of protein synthesis. Now, what we're not talking about tonight at all, but I'm just going to mention it for a few seconds, is the non-protein synthesis roles of amino acids. We're not putting down the non-protein synthesis roles. We're just not talking about them because we don't have enough time. So I don't want you to think that I'm anti non-protein synthesis, but you know, the reality of it is that the way that I learn this work and the way I've seen everyone else that I know learn this work is that we've always focused on the non-protein synthesis roles. Okay, so let me just do another quiz here for the couple hundred of you guys who are on this call, believe it or not. It's a popular topic. All right, you ready for this? I'm going to mention an amino acid, and you're going to say what comes to mind first. And don't filter it. Don't think, oh, what's the right answer? Serotonin. Oh, no, I said it backwards. Sorry. Let me say, I'm saying the amino acid, then you're saying the thing, right? Tyrosine. Okay, then somebody type in something. Tyrosine. Dopamine. Yeah, exactly. How about, let's see, what's an easy one like, oh, how about cysteine? Cysteine's pretty easy. What if I say cysteine? You should all think the same thing. Yeah, exactly. Glutathione, detoxification. Let's see. What's another super common one? I'll give you kind of a little tricky one. See if anyone get. How about if I say glycine? What would you think? Glycine. What's glycine do in the body? One of the things. Sleep, glutathione, methylation. Does it have anything to do with your gallbladder? Yeah, it's how you make bile salts. Also, phase 2 detox, exactly. So what everybody's putting in, as I name these amino acids, are the non-protein synthesis roles. It's not the wrong answer, but it's the least important thing that these amino acids are doing. So when you get an amino acid like tryptophan, its main role in human survival and health is not serotonin production. In fact, we have probably the majority of Americans are living, in a depressed state because they don't have enough serotonin or dopamine. Almost everybody in this country seems like they're depressed and overweight. So you can survive when you're not making enough brain chemicals, but you cannot survive if you're not running protein synthesis properly. You can survive with low glutathione. In fact, most of the patients that we test have low glutathione, but you can't survive without protein synthesis. So the main function of these amino acids is in the role that we're talking about them tonight, which is protein synthesis, but we're talking specifically about mitochondria and the stimulation of mTOR. Okay, there's all these other things though. So here are the 20 amino acids that you need. Most of the formulas that you're going to buy from the various supplement companies do not have all 20. You don't need to necessarily have all 20 because a lot of these amino acids make other amino acids, like glycine is how you make serine, and phenylalanine is how you make tyrosine and stuff like that. So any good company will have a variety of amino acids, and they'll have the ones that make the other ones in the formula. Just check the tryptophan thing because a lot of them omit tryptophan, and there's no substitute for tryptophan. You have to have that in the program or it won't work. So it's easy. Just buy a bottle of tryptophan. Pure Encapsulation sells it, and put like 1 tryptophan capsule in with each dose so that you level up and make sure that you have enough of that to get the protein synthesis going. Non-protein functions, we talk about that. Here's more non-protein functions. You guys already listed a bunch of these off. It's kind of cool, right? Like anything from arginine is a nitric oxide precursor that has to do with hypertension and blood vessel health. We've got carnitine. Well, lysine, which is how you produce carnitine. Tryptophan, we've already talked about, etc. So I'm going to skip some of these slides just so we have time to look at labs. So here's a picture of a mitochondria. I just think it looks cool, but there's really nothing to think about there. Here's the practical one though. So we want to make more of all of this stuff, right? And the way that you're going to see that there's mitochondrial retraction is you're going to see these various markers on the lab are low. Which ones? Well, citrate, cis-aconitate, succinate, fumarate, malate. If these markers are showing low in a consistent pattern, it means, could mean a couple things. It doesn't have to mean that they're hypometabolic. It's not a guarantee. There's other things that could cause this. So I don't want you to think this is a slam dunk. Like with everything in practice, you have to combine this with a good history, and it's got to make sense. If the person's like a professional weightlifter and they just won, the New Zealand championship weightlifting competition, and she's just like ripped and fit and feels great and has great sex drive, great energy levels, and she's like a model athlete, probably that's not what's happening. So the person's going to have chronic fatigue, depression, brain fog. They're not going to be super active physically. So just because the lab markers show something doesn't mean that that person is hypometabolic. You got to use your clinical judgment to assess this. And we're going to skip some of these more generic ones. Oh, these are kind of cool slides, but they're not really that important. So let's just take a look at, oh, and before we get to the lab testing review, let me just remind you, we have our level 1 and level 2 certification programs that we're launching for the first time this month. Pretty exciting. Level 1 is a series of 4 protocol design boot camps that include lab ordering and lab interpretation, learning the basic protocols for the labs. And you can look at the website to get the details on what they are. And then level 2 certification, also for classes. We're calling them workshop intensives because they're kind of extra intense. And they're a much more huge amount of curriculum for each one of them. You could join as a beginner of either. It's just that the level 2 is harder. It's just going to be more work. Level 1 is more introductory and not as much work. Okay. And then we have the mentorship program as always. All right, so let's look at some labs, and then let's talk about protocols, and then we'll get to questions. Now, this is unfair because, as I now know, because they're typing into this little thing here, we have like all these mentorship graduates that are coming to this class tonight. I don't know why, but hey, everybody, it's good to see you. There's Anna, there's J.E., there's Suresh, there's Diane, there's Jane. There's a bunch of you. So as I ask these questions, they're going to get them right, but maybe they're just here for a little refresher. Okay, let's see here. So let's take a look at a lab. So again, this is one of the tests that you can use. It's by Diagnostic Solutions. It's called an omics, OMX. And just like all the organic acids profiles, they have a big section here in the beginning on glycolysis and the Krebs cycle. And so we're looking for a pattern of low markers. And what do we see? Trying to make this as easy as possible. We see, okay, that one's high, that's high, that's high, these are all high here. So what does a high marker mean? When the markers are elevated, what does that mean? Anybody? It means that that enzyme isn't working, so that metabolite is building up. So that's an enzyme that's broken and not working very well. Maybe it's misfolded because of a SNP. Maybe it got damaged because of an environmental toxin, chemicals, heavy metals, a little spray of Roundup on your apple, that's going to damage these. Succinic acid or succinic dehydrogenase, that enzyme, particularly sensitive to environmental toxins. So environmental toxin can come in, take out that enzyme, this marker goes up, enzyme not working. Okay, so that's a mitochondrial problem. Now that's also going to mean the thyroid's not working great. However, from what we've seen in the classes that I teach, you can still fix the thyroid with this going on, you know? The cases where thyroid really was non-responsive were usually hypometabolic. So this is not a great scenario for the thyroid, but it's something I think that, you know, can be overcome by a good thyroid program typically. And so this is the traditional way that functional medicine doctors have looked at these organic acids markers for mitochondria. Again, it's a lightweight thyroid problem. Maybe thyroid's involved a little bit. Probably you have already corrected the thyroid and the person's feeling better. And then, of course, if you get the mitochondria working better, there's going to be even more of a, you know, sort of general benefit. Okay. So now let's look at one of these. Now, where'd it go here? Oops, sorry. I have a lot of windows open, people. It's a dangerous situation here. There. Okay, so this is a NutriVal from Genova Diagnostics. Very, very similar to the metabolomics test from Genova. And we're just gonna, now, the algorithms that these computers, that these labs run, see the algorithms here are not gonna pick this up because the algorithms are designed for high or elevated markers. Can I say that again? The algorithms that these labs have are designed by scientists that are like super smart and super good. And I have actually seen all the code that goes into developing these algorithms. And I am not putting these algorithms down because there's like years of work of teams of really smart people. However, they do not look at the hypometabolic pattern. So it's not picked up. It's not like there's something wrong with the algorithms. It's just a relatively new finding, and it hasn't trickled down to the point where the labs are, you know, willing to go out on a limb and call it. So now, if you look at this NutriVal, and again, it's fatty acid, carbohydrate metabolism, energy metabolism, you can see there's one or two markers kind of in the low normal range, 3 or 4 in the high normal range, a whole bunch of them are in the middle. It's not very suspicious. There's not that much going on there. But we're looking for, you know, we're thinking of pattern recognition. Here's another one. And, you know, if you were all in the mentorship class, you'd be doing this, you know, like 3 or 4 days a week. You'd just be looking at lab after lab after lab after lab. That's really how you learn this stuff. So now look at this one. Here's another NutriVal. And this one you see right away, oh, a whole bunch of those markers are high. Some of them are kind of borderline low, but that's clearly not hypometabolic. There's all kinds of mitochondria present to be spitting out these kinds of reactions. So again, high markers are not going to be what we're thinking about here. And let me find one more. So what I'm showing first are the ones that we're used to seeing that are familiar to all of us, and that, you know, we're used to, you know, this is how we all learn the work as well. Hang on one second. Okay, I'm a little crisis with the computer here. Hang on, give me one sec. I'm missing something that I had uploaded before, or downloaded, I guess, depending on how you want to look at it. I can't find it. I spent all this time getting ready and now I can't find it. Hang on one second. Just check your phone. You can look at your email. I can't find it now. All right, I'm going to have to kind of fake it as an example here. Well, let me do some question. No, let me try to just finish this off. So you're going to have to imagine this. I'm just going to draw it out on here because I can't pull up the right files. So you're going to have to imagine, just go along a little journey of imagination with me now. I'm going to draw in the markers. Let's say you have a test and it comes back, not like this one here, but it comes back with like this, like there, and that, like that, and this one like that. And maybe that one is normal, but then this one is low, and this one is low, and this one is low, and then this one is low. Okay, and so you've got, let's say the general definition that Dr. Lord has is more than 6 of these markers in the mitochondrial section are either borderline low or low. Get a situation like that, and it is the opposite of what we're talking about with the high markers. It is not that there's not enough metabolites being produced, it's that there's not enough mitochondria to produce them. And when this kind of a patient gets better and you start to improve their health, these markers come up, and it's very confusing to patients because it makes it look like on the lab, it looks like they're actually getting worse. Now, again, I'm going to say this for the second time, is that you have to kind of correlate this with the clinical picture, because not everybody with low markers is going to have this problem. It's not you have to kind of make sure that it makes sense, and they're going to have a history that reflects that, and you're going to see other lab markers that reflect that as well. All right. So let me just show you what a protocol design would look like for this particular situation. And now I'm going to do both programs. So we'll do the high marker version first, and then what we do for low markers next. And the high marker one, again, is sort of general. A lot of people do these all the time. And then the low marker one is a little extra special. It's more complicated and expensive. It takes longer to kick in, but boy, does it really work. All right. So let's pull up a protocol here, and I'll show you how to do this. So this is when you see the high markers. I just showed you a whole bunch of examples of markers being elevated. And there's a little mantra here. When I say mitochondria, you're going to think CoQ10, oxygen, and magnesium. So we're going to want to have CoQ10 in the protocol. And not a little bit of it, like a lot of it. 100 milligrams of it, at least 1 or 2 of those 3 times a day. Don't want to cheap out on the CoQ10. Magnesium, there's many different forms. I use glycinate most of the time, but you can use other forms. And then oxygen, we don't have to supplement, right? That's called breathing. Yeah, that should be easier to see. So CoQ10 and magnesium are where you get started. And then usually you can have like some kind of a multi-pack. I use these multi-packs from Pure. They're called the Energize packs. They're designed specifically for mitochondrial support. So I'll do that, but you can use any kind of pack that you want. And then, depending on the markers, but you're probably going to want to add carnitine. That usually comes in like a 250 or 350 milligram tablet, something like that. And you're going to want to use a fair amount of that. Let's say you get one that's got like 350 in it, just to keep the math easy here. You'd want to use maybe 2 of those 3 times a day. And then this is variable. I'll put a question mark on this one. You don't always need to do that. Let's cut the dosage back. How about that? It depends on the markers. We're not going to have time to talk about tonight. Let's just cut the dose back there. But if the carnitine markers are positive, you want to use the higher dose, like more like 2,000 a day. Now, B complex. There's going to be some Bs in the multi-pack, but generally not enough. And you need a lot of Bs to make this work. So this would be a typical protocol for markers that are elevated, right? Now, if you want to convert this would be the high mito markers program. If you want to convert this into the low mito markers program, let's just go down below. I'll just copy this so it's easy for us to see. Oh, that didn't work, did it? All right, well, we'll go back and just convert this one over. How's that? So low mito markers. You're gonna have to use the higher dose of CoQ10 because this person screwed up, right? There's that, there's the carnitine. You probably want to crank that up a little bit too. And then B complex, probably give more of that. And then the 2 ones you're going to add are going to include PQQ. That's usually done at around 20 milligrams once a day. That helps with what? Mitochondrial biogenesis. Mitochondrial biogenesis. And then the real kicker here, free-form amino acid powder. We talked about how much of it. Let's say around 10 grams, 2 times a day, away from meals. And what happens when you take that very large amount of a free-form amino acid powder on an empty stomach is your body goes, wow, this has never happened before in the history of humanity. There's a couple 100,000 years of human beings, and we've never gotten ever this much free-form amino acids. I mean, it's like eating a cow. Or if you're a vegan, it'd be like eating, I don't know, what do vegans eat that's high in protein? A lot of beans or something. I mean, there's no way you could eat food in a way that would all of a sudden flood your bloodstream with 10 grams of free amino acids in an instant. And so your body goes a little freaky and it's like, wow, there's just too much of this stuff lying around. What am I going to do? Oh, I'm going to build proteins. So let's get mTOR up and running and start making stuff. Why? Because we've got all these amino acids to make stuff with. And if you do this for 3 to 6 months and you retest the person, you'll see their labs coming back. Thank you, Lisa. Hemp seeds, that's a good one. You'll see the labs come back. You'll be like, whoa, I can't believe these low markers are better. How are you feeling? Well, I don't know, but my depression is gone. Well, I don't know, but my fatigue is gone. And then apropos of tonight's class, I don't know, but I think the thyroid medications are finally working. You cannot get successful thyroid outcomes if you don't have enough mitochondria present. I have seen great success with thyroid programs with the high markers on the labs, but not much with the low markers. Okay, so now let us take a pause for a moment. Let me see here. We have a few minutes left, so let me look at questions. And there's one other thing I wanted to mention for those of you that are new. Okay, I just want to show this. As you've learned, I'm really into QR codes. And I've got another one for you right here. So let me just pull it up. And let's see if you guys can get this to work on your phone. I don't know why I'm so into QR codes. It's just like the thing. Okay, so here's a QR code. I should probably tell you what it's for. So this is a QR code for Rupa Health. So if you're not ordering labs from Rupa yet, scan this. It gets you a $100 discount on your first set of Rupa labs. And that's kind of cool because it's a great service. If you don't know about Rupa, it's a lab distribution service. They have all the lab test kits that I just mentioned under one roof, and they take care of all the lab ordering and processing and admin. And it's like the best thing that's happened to functional medicine practices in the last 5-6 years in terms of efficiency and just less stress for the doctor. So this is a magical QR code for Rupa Health's discount. I didn't want to forget about that. And I'm sure we can send that out in an email, and we probably will send all of you an email tomorrow with this, with the recording and all that, okay? All right, so now let's get down to some questions. Let's see here, hang on a second. Okay, can you do the free-form amino acids at bedtime without issue? Most of the time, I wouldn't do that though. They're kind of energizing, so it's better to do the dosages first thing in the morning when the person first wakes up, and then sometime between breakfast and lunch. Or maybe if that doesn't work, like 2 or 3 in the afternoon, be a little safer because you don't want to stimulate them too much later in the day. Is this protocol introduced after addressing toxins, mold, etc., which are impacting thyroid and mitochondria? That's a good question. That is from Michelle. Well, you know, I have an opinion about that that's just based on having watched a lot of cases of my own and watched hundreds and hundreds and hundreds of cases every year in the mentorship class. So in the mentorship class, it's a one-year program. So I'm with these doctors for a while, and they're submitting a lot of cases, and a lot of them have time to actually retest their patients, and we get to see if things are working or not. And so at this point in my career, I don't only have my own clinical experience, but I have the clinical experience of every single mentorship student, you know, and all the labs that they've submitted. And so that stuff is all kind of stuck in the back of my brain. But what I would say is that lack of mitochondrial populations is going to make it impossible to detox, to get rid of mold, to get rid of metals. the way I explain it to patients is your liver detox pathways, phase 1 and phase 2, it's like a laundry machine or with the washer and dryer. And if you unplug them from the wall and they don't have any juice or power, they're not going to get anything done. So if your liver doesn't have enough mitochondrial energy, enough ATP, it ain't nothing going to get detoxed. So in terms of strategy and sequencing, I think that the mitochondrial repair, not the high marker patterns, but the low marker patterns, the hypometabolic states, have to come in the very beginning of a program so that you can get the brain chemistry working, so that you can get the liver detoxed, so you can get the gut working. I think it has to be a basic treatment that you do in the very beginning. Now, are the mitochondria still getting damaged by the mold or the environmental toxin? Well, yeah, they are, but you're getting them fixed so quickly that the damage thing is kind of overcome. That buys you the time then to start to get, all the other stuff fixed that you need to get fixed. So I guess the short answer to that is, yeah, I think you have to do this, in the very, very beginning in order to really, get a result that your patients are going to be happy with. Let me see here. So many windows. Here we go. All right. We keep going with questions. Supplement program with an enlarged prostate. I don't think that's contraindicated. Yeah, I don't think we're okay on that. Time restricted eating or intermittent fasting. Taking amino acids are not going to change. Well, I shouldn't say that so cavalierly, should I? So let's think about it. Why are people doing intermittent fasting in the first place? What are they trying here? I'm picking on Jolene now, who asked the question. Why, in terms of mTor, why are people intermittent fasting? They're trying to stop mTor, not stimulate it. But I think when you listen to the researchers on mTor, really you're trying to get mTor running and then slow it down. Trying to get mTor running and then slow it down. And slowing down mTor is one of the main, if not the main ways that people have found to extend lifespan of mice. And I'm really interested in protecting the lifespan of mice. That's one of my. I'm just kidding. I don't care how long mice live, but obviously they're trying to apply this to human beings. And so, intermittent fasting, time-restricted eating, and just calorie restriction in general are going to slow mTOR down. And what we're doing with the large dose of amino acids is speeding mTOR up. I've talked to a lot of doctors about this. I think you can pulse it. I think you can speed up mTOR, slow it down, speed it up, slow it down. And in fact, that's probably what happens when you're doing intermittent fasting, because you can't fast forever. You'd be dead. And then it wouldn't matter what's happening with your mitochondria because you'd be dead. So if you fast for a while and then eat, you're kind of stimulating and slowing down mTOR anyways. I don't think if the person has damaged mitochondria, then you have to do this program. It's way more important than any of these other variables that we're talking about, because the lack of mitochondria is going to overtake everything else in terms of you trying to fix other stuff. This is from Dina, can amino acids help with vitamin D absorption? I don't know. That's a good question, and I'm not sure about that one. Oh, okay, 10 points for Diane. How important is resistance training for restoring mitochondrial health and quality? So I'm glad you brought that up. So we're going to talk about this for like 5 minutes because this is an important question. So thank you, Diane, for asking that. So let's think about it. Let's think about it in terms of cars, because I really like cars. I hope that doesn't offend anybody. I like bicycles too, but I like cars. I don't drive very often. I ride my bike everywhere, but I really like cars. So if you take a car and the engine's broken, that would be like the high markers on the mitochondrial metabolic profile. Okay, the engine is still there, it's just not working that well. What we're talking about with this example, with a hypometabolic state where the thyroid's involved, or not, the thyroid's involved because it's not working, it's like the engine was just gone. Okay, that's a pretty big problem. So let's say that you replace the engine in your car and you've got all these mitochondria back now. The engine's back in the car, but it doesn't have any gasoline. Is it going to do anything? No. So developing mitochondria fully requires the engine to be there, right? And then you have to have the gasoline for this whole thing to come together and work. So just doing the supplementation programs is going to be kind of like getting the engine back but not having any gas. The car is going to be like a little bit better but not really work. So the essential component to making this come together is exercise. And there's two forms of exercise that really matter. One is going to be strength training. One is going to be strength training because when you do strength training, it forces your body to do what? Build more mitochondria. Can you do that if you are hypometabolic? Not very well. Can you do that if you're hypometabolic and are taking amino acids? Yes, and every weightlifter bodybuilder knows that. That's why they are chugging down raw eggs and eating cans of tuna and drinking whey protein like crazy people, because that's how you build muscle. Is you have to have the amino acids that we're talking about tonight, and you have to have the resistance training in order to get these mitochondria back. So taking the supplements without the resistance training is futile. However, and this is a big however, a lot of our patients who have this problem and have chronic fatigue are not going to jump into the gym and start pumping iron. They can't because they're so tired. So you got to let them know in the beginning, this is probably the most important thing I can say tonight. As soon as your energy levels are better from the supplement program, we want to get you in the gym, starting to do some resistance training, because that's going to take over as the main driver. That's going to take over as the main driver of mitochondrial growth. The exercise will. And when these supplements are gone in a year, you're going to keep your mitochondrial populations intact by doing resistance training. So Diane, again, thank you for asking that question. That's the most important question anyone could ask. Now, there's one other question, and I don't know if it's on here, but I think it's as equally important, which is that in order for mitochondria to be efficient, so let's say you've got your mitochondria back, you've done your resistance training, you've got all the muscle mass that you need to function well. To make the mitochondria efficient, what do you need to do? Does anybody know? And now I'm going to ask this as a question. Somebody type in, what makes mitochondria more efficient? I'm going to go to the section and show you what makes mitochondria more beta oxidation. Beta oxidation. And we measure that on these tests. Beta oxidation sitting right there, fatty acid metabolism. So you also need to do eventually zone 2 exercise to make the mitochondria more efficient in using fats for fuel. That's why you have to do cardio and strength training in order for mitochondria to be at their peak. And again, the supplement programs are designed for temporary use to get the person over the hump so you can get them into the gym and get them working out, get them doing strength training for mitochondrial growth and biogenesis, and then cardio in zone 2, not high intensity, that's a sort of a separate subject, cardio in zone 2 for mitochondrial efficiency. Now, if they're in really good shape, then they can do, more exercise. Okay. Hi, Suresh and Jay. It's really great to have these old students. By the way, any of you guys who are in the Bay Area, I'm going to be at the Lens conference. So Doctors Data has their annual conference. It's in San Francisco this year. It's in February. Just go to the Doctors Data website. I'm going to be there for 2 or 3 days. Any of my former students who are around, if you want to go to that conference, we can go out for lunch together and meet, and that'd be really great. Doctors Data Lens conference in February. Let's see here. Now, Hashimoto's specifically. So Hashimoto's obviously an autoimmune problem. You would do all the standard thyroid treatments, but then you need to go on a hunt to figure out where the autoimmunity is coming from. Is it yeast overgrowth? Is it mercury toxicity? Is it a bad marriage? Is it alcoholism? A lot of things can cause autoimmunity. Long haul COVID and COVID vaccine injuries can cause autoimmunity. I see that every day would be an exaggeration, but every week I see that somewhere in my practice or in our classes. So with autoimmune thyroid, you have to fix the thyroid, fix the mitochondria, but independently find the source of autoimmunity. That's very important. PQQ is the mitochondrial biogenesis product, the one that helps mitochondria grow. For some people, keto diets work really well. That's kind of on an individual basis, but it can be an important component to this. Yeah, and if you're having any problems with antibodies, then again, you need to, find the source of why the body's reacting that way. That's sort of a separate topic, really, than tonight. Yeah, for any kind of cancer, I would not stimulate mTOR, even skin cancer. So what does empty stomach mean? Empty stomach means an hour or two or more after a meal and 20 or 30 minutes or more before a meal. So 30 minutes before a meal, absolutely fine. And by the way, you want to hear something very convenient is that your patients with leaky gut that have really screwed up digestion, some of them are going to react horribly to these amino acids. It's going to give them all kinds of GI problems because sometimes bacteria in the gut feed on the aminos. So that's going to be a disaster. I'm just warning you. That's not funny, but I should have a slide on side effects. So if the person reacts poorly to amino acids, just stop and fix their gut. Okay. But for a lot of other people that have uh, gut-related problems, the amino acids are going to get absorbed instantly, assuming that they can tolerate them, because you don't have to digest them; they go right into your bloodstream. Let's see. I don't know enough about type 1 diabetics in terms of having tested enough of them to give any comment on that, so I'm really not sure about that. Uh, and then, if the person has a you're only going to be doing these programs for a short period of time, 6 months, maybe a year. So you're not putting anyone at really great risk by doing these. Just don't do these forever. Just short term. Okay, we're almost done with questions. We got another minute here before we're out of time. Let's see, amino acid deficiency is implicated in anorexia. I think I've worked a lot with eating disorders, and every patient I've had with an eating disorder, obviously has a pretty bad adrenal stress hormone problem, detoxification issues, obviously leaky gut, food allergies, food reactions. Um, they're going to pretty much always have amino acid problems. They kind of have to if they have an eating disorder. Um, do you have to take level 1 and level 2 to join the mentorship? No, the mentorship's open for anybody at any level at any time. If you want to devote a year to doing this, I will train you personally in being the best you can be. It's like, I don't know, Navy SEALs of functional medicine training. So anyone at any level can join the mentorship. We have people who just graduated from medical school. We've got people who um, I've been in dental practices for 40 years. We have chiropractors and acupuncturists and nurse practitioners and medical doctors. We have people that have done IFM and done it twice, and we have people that have just learned what functional medicine was like a month ago. So the mentorship is a real mix of all kinds of levels of people, and we're kind of focused on that. Um, let's see. Uh, Let me see. Suresh has got a question here. He's always got good questions. So let me read this out for you guys. So hi Dan, I just saw something. Suresh is mentorship grad, is like super smart guy. Hey Suresh, I hadn't thought of it before, but if you have multiple elevated levels of markers for Krebs cycle glycolysis, could it also mean that some amino acids are missing, leading to multiple enzymes not functioning correctly? And would you want to do the same mTOR activating dose of free-form amino acids? That's CD, Suresh. This is a deep question. You have to think about it. Suresh's questions for a while. No, I got to go with a no on that one. I think if you see multiple enzymes screwed up, I would still go with the lower dose. And if you guess wrong on that one, that's not going to matter that much because you're going to retest the person and you'll see if you did the right thing or not. But I think the lower dose would be better for what Suresh is asking. Ed is asking, had a hypometabolic patient, all the essential aminos metabolomics were on the high side. How would you approach that? Yeah. Oh, okay. I'm going to end on this thought. So low amino acids or high amino acids on a lab test have nothing to do with what we're talking about tonight. Does that confuse anybody? I hope that confuses all of you. It should if you're still listening, okay? So let me say that one more time. Low amino acids or high amino acids on one of these tests bears no relationship to what we're talking about tonight at all. You could have a problem with, let me see if I have an example here. Here's some bunch of amino acids here. You could have a problem with hypometabolic states with a patient with low amino acids on the labs, high amino acids on the labs. It's an independent variable, okay? Now, I want you to type in, I'm confused if you're confused, just so I can see how many of you I just confused. I hope I confused a bunch of you. Is anybody confused by that? This is not a deficiency state of amino acids, okay? Oh, good, thank you. A few of you are saying you're confused. So, and I'm gonna end on this thought because this is a really profound thing and you wanna think about this, and this is really important for all the clinical practice stuff that you do. You ready for this? So, there's two completely separate things that are happening that we're talking about. You can be deficient in an amino acid, which means your body doesn't have enough of that amino acid, and you need to take that amino acid so you can have normal amino acid levels. And that's going to affect protein synthesis, and it's going to affect the non-protein functions of amino acids both. You could have normal or even high amino acids on the amino acid test and still be hypometabolic. So we're using amino acids in a hypometabolic treatment, not because the person's deficient in them. We're using it to stimulate mTOR. It's a whole different thing. Let me give you an easier example. You could have a patient that tests as low in magnesium, and you give them magnesium, and now they feel better and sleep better and have more energy. You could have a patient that has normal magnesium levels already, the normal magnesium, and you give them magnesium because you want to lower their blood pressure because it's a vasodilator. You're using the magnesium not because there's a deficiency state. You're using the magnesium like you would use a blood pressure medication because magnesium lowers your blood pressure. Okay, so you can use the exact same supplement to replace a deficiency and as you can to have it act in a drug-like way to have a certain biochemical effect. So everything we're talking about tonight is for people who have lack of mitochondria. They may or may not test with low amino acids. Of course, a lot of them are going to, but it's not a requirement. And we're not using these amino acid formulas to replace missing amino acids. We're using them to stimulate mTOR. Okay, that's super important. So in other words, if you get a lab back and the amino acids are all really good or even high and the mitochondrial markers are low, you still are using amino acids, not to treat the amino acids, you're treating mTOR. Oh my gosh, so many good questions. I'm sorry I didn't get to all of them. And this is not judgmental. I just started at the top and went down and we're just out of time, you guys. This is a mentorship mini series, which means there's more of these coming up. So keep an eye on your email. I believe there's one next week. If you haven't ordered from Rupa yet, order from Rupa. Here's the code. Let's try to scan that thing in your phone. If you haven't taken one of our boot camps, you can sign up with those earlier codes. And we'll be sending out emails tomorrow as well with a link to the recording and a bunch of other information for you about the new certifications that we have. Okay? All right, take care, everyone. We'll talk to you guys soon. Bye now.